Hello everyone and welcome to .NET Code Central. In today's video, I am going to talk about strategy design pattern. Strategy design pattern is also a design pattern from the Gang of Four design pattern. And strategy pattern is a behavioral design pattern. The main intent of this pattern is to define a family of algorithms, encapsulate each one so that they are easily interchangeable. This allows the algorithm to vary independent of the client using it. Now, once we get into the implementation, it will be much more clearer what it means. But at a high level, it is essentially creating a contract and then implementing different algorithm on the contract and let the client use the contract. And then if you want to change the behavior of the client, you just swap the implementation of the contract with another implementation and the client will behave differently. That way the logic of client can be changed irrespective of what the algorithm, and similarly the algorithm can be changed irrespective of what the behavior of the client. That is in a nutshell what this pattern is all about. But just like most of the design pattern, if we are implementing solid design pattern properly and implementing single responsibility principle, strategy design pattern will come out of box with that. So first let me go and implement it. And places where this particular design pattern fits very well is where we need to have multiple algorithms. For example, there are situations where we might have to have different type of encryption. Similarly, one of the other extremely standard example is sorting. So if we have to deal with sorting of different number, then the sorting logic is what we can implement as a strategy. So to achieve that, let me create an interface and a class associated to it. So I'm going to create one file for sort, and I'm going to implement couple of sorting algorithm. I'm going to implement the quick sort and bubble sort. And I'm going to keep both the implementation in the same file for the time being, but we can use different files for all the class and interfaces. So I'll create a class file called sort. Let me get rid of all the unnecessary namespaces. And I am creating this project in .NET 6. And I can name this as quick sort. And here what I can do is I can create an interface. And I'm going to name it as iSortStrategy. And it's going to have a single method which returns an int array. I have a method called sort, which takes again an array of int, and it can be input array. And here we're going to implement the iSort strategy and implement the interface. So here we are going to implement the quicksort, and quicksort implementation, it's pretty straightforward. In a quicksort, when we sort an array, we start with the midpoint and then we figure out if something is less than the midpoint, then we put it onto a left collection. And if it is greater than the midpoint, we put it into the right collection, and then finally merge the left, the midpoint, and the right array and create the sorted array. So for that, what we can do is we can create if input array is null, or input array dot length is less than equal to 1, then just return the input array. And then what we can do is we can get the center point of the array. So we can define var. First we get the index, and it's going to be input array dot length divided by 2. That's the center point. And then we can have our center value, which is nothing but index array of center index. It is the index of that. And then we can create couple of lists. So we can say var left part equal to new list integer. And then similarly we can have right part, which is a list of integer. Then we'll create a for loop, and for the for loop we're going to loop through the entire array, and then if the I is equal to the center index, then we just want to continue. But if it is not, then we're going to check if the input array of I is less than or equal to center value, then we're going to add it to left part. But we are going to add the input array of I to the left part. Else we're just going to add it to the right part. And that is pretty much it. So this is going to create the whole left and right. And then what we want to do is we want to basically do it in a recursive manner. So for that we'll have our sorted is equal to, we're going to call the same method sort, and this time we're going to pass the left part dot to array, and then convert it to a list. And then what we'll do is we'll do sorted dot add. So here we got all the left part sorted, and then we'll add the center value. And after that what we are going to do is we are going to now sort the right part and add it to this sorted list. So we can do sorted dot add range, and here what we are going to do is we are again going to call the sort, and we are going to pass the right part dot to array. That is pretty much it. And after that what we can do is we can return sorted dot to array. So this is going to return the sorted list back, and this is the quick sort. And then we can create another class for bubble sort because this class has taken the entire monitor space. So I'm going to create another class, and I'm going to name it as bubble sort, and I can just get rid of the namespaces. Name this, and this is also going to implement I sort strategy. I'll implement the interface, and now here we're going to implement the bubble sort. So bubble sort is basically, it's a simple sorting where we compare each adjacent item, and then based on the order we swap them. It is also pretty straightforward. So we're going to implement that, and for that what I'm going to do is I'm going to create a return array. So I'll create a return array equal to input array, and then what I can do is I can declare var length is equal to return array dot length. That's the length of the array. And then we can create a couple of loops. So first we can create a loop for each I where I is less than length minus 1 and I plus plus, and inside of that we can create another for loop where we can declare j, and j is equal to length minus I minus 1 because we want to do 1 less, and then j plus plus. And inside of that what we can do is, now here we can say, okay, if the return array of j is greater than, because we have to compare the adjacent items. So if return array of j is greater than the return array of j plus 1, if that is the case, then what we can do is we can create a temporary variable temp is equal to return array of j, and then we can do return array of j is equal to return array of j plus 1. We take the next item because that is the smaller one, and since the j plus 1 is bigger, we can say return of j plus 1 equal to 10. So we are now sorting it, and this will happen from 0 to n minus I minus 1, and then it will go up again to the higher loop and start from the next one, and it will continue until the entire loop is sorted, and then in the end it is just going to return the return array back to the caller. So these are the two strategies that we have created. Now we need the client which will be using this strategy. And for the client, let's say we want a type which is sorted numbers itself. So we can create a new class, and this is the client class which is going to use the strategy. So for that, we can create something called sorted numbers. So that's the class. Okay, so for the sorted number, we can create a constructor here, because this needs to, the strategy needs to be injected. So we can have I sort strategy, and we can declare the sort strategy, and then it is going to have a sort method. So for that, we can have a public void sort. It takes an int array of items, and here what we can do is we can have sorted equal to the sort strategy dot sort of items, and then we can just print item in sorted, and then here we can just do console dot write line item. It's pretty straightforward implementation. And let's get rid of these namespaces because we don't need them, and let's implement an interface just for the best practice, as I always do. So now we had the sorted numbers, which uses the strategy. Sorted number is the client, and then based on the strategy, its implementation and output will be different. Now if we go to program class, first let's add the using statement for the strategy pattern dot demo namespace. And then what we can do is we can declare items, and this is equal to new, and here we can have random numbers, let's say 88, 54, 4, 87, 15, 8, 105, and this is the array. And then what we can do is we can say var sorted numbers equal to new sorted numbers, and here we can first pass the bubble sort as the strategy, and then we can do sorted number dot sort of the items. And let's create a delineator here, and then after that we can again declare sorted numbers. The number spelling is incorrect, so let's fix this. So we can have sorted numbers is equal to, I'm just redeclaring sorted number, and this time instead of bubble sort, we're going to have quick sort as the strategy, and then we can do the same thing, sorted number dot sort, and we can pass the items. And now if we run the application, both the time it is going to sort, but based on the strategy it's going to use a different sorting mechanism. And if we run it, and here we can see initially it used the bubble sort, and then it used the quick sort, and both cases it sorted the same way, just that it performed two different strategies for sorting. And now as you can see from the implementation, if you are using solid design principle, your implementation will look exactly the same, because you will end up creating a sort strategy which is an interface for different sorting type, and then you will end up creating a quick sort and bubble sort, two different classes implementing the same strategy. And then the client is going to get the strategy injected, and based on the strategy it will have different behavior. So as I mentioned earlier, with solid design principle you kind of get it out of box, but it's important to understand this pattern so that in a situation like this we can implement appropriate implementation, rather than trying to have a sorted number and have if-else condition and do all the logic here. This is a better separation of concern as well as single responsibility principle implemented. So that is all I wanted to cover for today's video. If you like this video, please give me a thumbs up. If you are new to my channel and if you think you are getting value out of my channel, please subscribe to my channel. And thanks so much for watching this video.